This lesson is about radians. Radians is just an alternative method of measuring angles. So we've got degrees, which we're most familiar with. There's radians, there's also mils, all these other different ways of measuring angles. Radians is another one. So the reason why we like radians so much is because a radian is a number, whereas degrees have this degree sign after it. So radians will let us do some modeling for real situations and be able to graph functions, whereas degrees would always have to convert back to real numbers. So an angle in radians is found by dividing the arc length by the radius. So what that means is, in this diagram here, the arc length here is 1, the radius of the arc is 1. So if I do arc length divided by radius, I'll get 1. So this angle in here is 1 radian. When I have angles in radians, I can either write it with a superscript C, superscript R. I can write the word rad after it, but more likely we'll just write 1 without any sign after it. So what we'll be able to do by the end of this lesson is convert between radians and degrees and have an idea of some common angles in radians and degrees. So using this third dot point, if I want to find out how many radians is 360 degrees, so I can get some conversions, I know that the distance around this circle is 2 pi. So the angle all the way around the circle, which we know is 360 degrees, is found by dividing the arc length by the radius. The arc length is 2 pi divided by the radius of 1, so 2 pi radians. So I can write that 360 degrees equals 2 pi. I'm not going to write C or R or rad after it. I'll just leave it there as a number. So this is a pretty useful thing that we'll be able to use for conversions if we want. What's probably more convenient is knowing what 180 degrees is. So I'll use the same idea, divide the arc length by the radius. So I know this arc length, this distance around here is pi. So pi divided by the radius, which is 1, gives me pi. So what I can write is that 180 degrees is pi radians. So this is pretty much one that we'll put in a box and color because it's what we're going to use for the majority of our conversions. That 180 degrees is pi radians. Okay? And you have the bonus of knowing actually why that is the case, not just learning it by rote. So what I could do here is I can find out what 1 degree is, okay, by dividing both sides by 180. Okay, so 1 degree is pi on 180 radians. And I can go the other way as well, that 1 radian, dividing both sides of the yellow thing by pi, is 180 on pi degrees. So I can use those for conversions. But before we do some actual just typing in numbers conversions, I want to just have a look at the circle and see if we can find some of these common angles. So I'll start with 0 degrees. I know 0 degrees is 0 radians. I know 360 degrees is also 2 pi radians. And from that previous diagram, 180 degrees is pi radians. So what I'll be able to do is use this idea to find what 90 degrees is in radians. I know that 180 is pi. 90 degrees is only halfway, so it's going to be pi on 2. And I could do a similar thing down at 270. I know that 270 is, well, that's pi, and then there's another pi on 2, so it would be pi plus pi on 2. Need to get comfortable adding these fractions. Pi plus pi on 2 what we're really doing is adding 1 plus a half. Okay, I know that that's 3 on 2, but I've got this pi coming along for the right as well. So this angle here is 3 pi on 2. Another way of thinking about it is start at 0, then I have 1 pi on 2, this is 2 pi on 2, because these 2's would cancel, and then 3 pi on 2, and then here 4 pi on 2, 4 divided by 2 is 2 pi. Okay, so there's different ways of conceptualizing that. Now I can have a look at the thirds. So again, I know that to 180 degrees is pi. What if I wanted to know what 60 degrees was? I'd think, well, 60 degrees is 1/3 of 180. So 1/3 of pi would be pi on 3. And then I can go around the circle just using thirds. So 60 degrees is 1/3. I know that 120 degrees is double that. Okay, so 2/3 or 2 pi on 3. I get around to 180, so I go another 60 degrees, 3 pi on 3, which is pi, which is good. And then I can come around to 240 degrees, which is another pi on 3. So I had 3 pi on 3. I've now got 4 pi on 3. And then another 60 degrees, so another pi on 3. So I'll have 5 pi on 3. And then to 360 would be yet another pi on 3, or 6 pi on 3, which is 2 pi. So all of that sort of works. Okay, so we need to be able to work these angles out. You might have a different way of doing it, but you need to be comfortable with these fractions. Going to be using them for the next 2 years. Then we can have a look at the quarters. So for example, 45 degrees. I know that it takes 1, 2, 3, 4 45 degrees to get to 180. So I know that 45 degrees is really pi on 4. Okay, 2 lots of this, 2 lots of pi on 4 is pi on 2, which is good. Go around again to 135. This is 3 lots of pi on 4. So 3 pi on 4. Keep going, 180 degrees, that's 4 pi on 4, so as a check, yep, that works good. To 225, another pi on 4. 3 pi on 4 at 270, yeah, that's really 6 pi on 4 simplified, that's okay. 315, another pi on 4, so 7 pi on 4. And we get around to the end at 8 pi on 4, which cancels out to 2 as well. Okay, so pi on 4s work exactly the same as the pi on 3s, but you just need to get comfortable in your own way of being able to do these conversions. Okay, the final one is 30 degrees. Okay, so it requires 6 times around, so it'll be pi on 6s. I could work my way around here, but I need to get comfortable doing this other idea as well. So at 180 degrees, to get to 150, I need to go back or subtract pi on 6. So I need to be able to do pi minus pi on 6. This is really 1 minus a sixth, which is 5 on 6. Or you can do the calculation properly. So give them a common denominator of 6. Okay, just multiplying top and bottom by 6. And then I'll have 6 pi minus pi on 6, which is really 5 pi on 6. Okay, so that's how I can get to 5 pi on 6 for 150 degrees. In a similar way down here, this is really pi plus pi on 6. Okay, so I have 1 pi plus a sixth of a pi. I really have 7 pi on 6. And the only one that's missing is over here, 330 degrees. So this is really 2 pi. So the whole way around the circle, subtract pi on 6. So I'll do this one with the 2 pi minus pi on 6. Give them both a denominator of 6. So multiply the top one by 6, so I get 12 pi. So I'll end up with 12 pi minus pi, 11 pi on 6. And that completes all of these basic angles. Okay, so you might be thinking, well, what happens if I have an angle like 15 degrees or pi radians? These are the two conversion tools that we'll use in those cases. So degrees to radians, I want to multiply by pi on 180. Radians to degrees, I want to multiply by 180 over pi. Okay, so to do these conversions, convert an angle in radians to degrees, multiply by 180 on pi. I've got pi on 12 radians, I want to convert it to degrees, so pi on 12 will be the same as pi on 12 times 180 over pi degrees. And then just off to my calculator for that. Okay, it's the same as 15 degrees. Okay, you can do part B by yourself. But from degrees to radians, multiply by pi on 180. So my 30 degrees will be the same as 30 times pi on 180 radians. I can put it into my calculator, and your modern calculator should simplify this to pi on 6 radians, okay, which is what we know from just starting with pi equals 180 and dividing both by 6. Okay, you can do the last one by yourself. There you go. And here's some questions to practice those skills. Okay, but the biggest thing is probably to be comfortable with converting any of these basic angles. All right, good luck.